having us along this evening to your meeting. So I'm Eleanor Shipton. I'm Communications and Engagement Lead for the Havant Thicket Reservoir project, and I've been involved with the project for about 4.5 years. And I'm joined today by my two colleagues, Ryan and Mark. So Mark, I'll start with you if you'd like to introduce yourself as well.
Yeah, no problem at all. Good evening, everybody. My name's Mark Jessup. I work for Portsmouth Water. I'm the environmental manager on the Havant Thicket Reservoir project. I joined the project at the beginning of 2024. It's a very exciting project for anybody involved in the environmental field because it's an environmentally led project. Prior to that, I'd worked for 6 years on HS2, well, actually for HS2, which is a very different project in the fact that most of your environmental work is quite reactive, where this is definitely environmentally led, which is what drew me to the project. So it's very good to meet you this evening. I look forward to providing you an update on some of the related environmental work that we've been doing to mitigate impacts from the reservoir.
And Ryan, we hand over to you.
Brilliant. Good evening. My name is Ryan. I'm the Earthworks project manager with Future Water. Future Water is a joint venture of two companies, Jones Brothers and Macleys. I'm part of the Jones Brothers side of things, which does the earthworks. So it's my job to keep the big yellow machines running as efficiently as possible. So I'm going to talk a little bit about the construction processes that we've got going on the site, and also hopefully cover off a bit of technology and innovation. I will caveat that in that the construction industry tends to be a few years behind other sectors. Actually did quite an interesting dissertation on it a few years ago. But I've been in the industry for about 6 or 7 years now, and I've been on Havant Thicket since November 23, so pretty much 2 years to the date. Before that, I worked on highways, so I worked for a local company called Dyer and Butler. So I've worked on a few highway schemes around the county. So yeah, look forward to talking to you all.
Brilliant, thank you both. So I'm going to start today with a bit of an introduction about the reservoir. So we'll talk about why it's needed and give you an overview of what's been happening on site and also more broadly across the project. So before we start talking about the reservoir itself and why it's needed, I think it's really important to put it in the context of what's happening nationally across the country. So we're looking at a shortfall of nearly 5 billion litres of water per day across England. That's by 2050. So it's a really enormous amount for water companies to find. So this shortfall is actually more than a third of the 14 billion litres of water that is currently put into public water supply across the country today. There are a number of different factors for this, so where this shortfall is coming from. And I think a lot of people assume it's mostly driven perhaps by climate change or a growing population. And while they are contributing factors, the real driver behind this is the environment and the need to protect and improve our environment, particularly some of our very precious rivers. So this situation is replicated here in the southeast, and we're facing a deficit of more than 2.6 billion litres per day by 2050. It's again, the real driver here is the environment and particularly the need to protect our precious chalk streams. So there are very few chalk streams in the world, as some of you might be aware. It's about 200 in total, and the majority of those can be found in southern and eastern England. We're looking at a range of different solutions, not just building a new reservoir, so moving water from areas where it's more available to where it's needed, and also looking at new technologies, including water recycling and desalinated seawater. But one thing that we are doing is building the new Havant Thicket Reservoir. This will be the first major new UK reservoir to be built in over 30 years. It's actually being built, as we talked a bit about, to protect the environment, particularly rare chalk streams. In particular, 2 chalk streams in southern water supply area. So southern water is our neighbouring drinking water company, and they supply customers in a range of places across the southeast, but one of those is in the Southampton area. At the moment, they take a lot of their supplies from two chalk streams, the River Test and the River Itchen. But because of the really sort of rare and important nature of these two habitats, they've agreed to take less from these two rivers, which is going to leave the company with a deficit of around 200 million litres of water per day. So Portsmouth Water has agreed to help and is in a position to help with this challenge. And that's why we're building the new Havant Thicket Reservoir. So under current plans, the reservoir will be able to supply 21 million litres of water per day to Southern Water. The reservoir itself will supply Portsmouth Water's customers, but this will free up our supplies further to the west, enabling us to share this 21 million litres with Southern Water. We've got some sort of key facts and figures here. So the reservoir will be 5 kilometres in circumference. It will be able to hold up to 8.7 billion litres of water, and 22 metres, that's the height of the main reservoir embankment. And if you look on that picture there, the main reservoir embankment is that stretch to the right of the picture, where there is, you can see sort of gradient steps up and a little sort of round viewing area. So as well as protecting these chalk streams and being, as Mark said, an environmentally led project, the reservoir will deliver in its own right a significant environmental net gain for the area. So as part of the project, we're planting more than 200 hectares of woodland and wood pasture in the local area. We've gone above and beyond the commitments we made in our planning application to the environment, and we're actually working with the local community and volunteers on projects to translocate trees from site. So to date, we've translocated more than 450 tree saplings and plants from within the reservoir site footprint. When the project's finished, it will also become a new green leisure hub for the area. So it will have a visitor centre, a wetland, bird hides, and will be a real environmental focal point for the area, as well as somewhere for the community to come and enjoy. So talking about the community, so we actively involve our local community. A big part of this is going out and delivering talks like this. We also welcome groups to site. We go out and about and go to local community events. And a big part of the work we do is to engage with local schools and colleges to update them about the project. And we actually have a small group made up of representatives from local schools, about 20 children in total, and they're student ambassadors for the project. So they come to site every half term or so. They carry out activities with us, they learn about the project, and then they take those learnings back to their schools. So as well as engaging with the community directly, we also have a really well-established group of stakeholders. So when we talk about stakeholders, we mean representatives from more perhaps official groups, including so local councillors, representatives from community groups. We've got head teachers, we've got representatives from environmental groups, including the Hampshire back group. And this main stakeholder group now has about 70 members, and they meet as a whole about quarterly, but they also meet far more regularly to look at specific aspects of the project in more detail. So they're looking at opportunities around education, the local economy, the environment, and this is some of the stakeholders in the picture. This was them out looking at some of the trees which had been translocated. So as well as providing some real sort of environmental benefits, as we've talked about, the reservoir will also have economic benefits for the local area, and we commissioned a study to understand this in more detail. So this was carried out by the University of Birmingham with the support of 9 of the contractors involved with the project, and Future Water, which Ryan is representing, was one of those. So the project is expected to generate more than £50 million to the southeast economy during construction. This be include 84 new construction jobs and between 15 and 20 apprenticeships across the duration, although we're hoping to exceed this. So we've talked a lot about the reservoir itself, but not so much about where the water will be coming from. So under the current approved plans for the scheme, water to fill the reservoir will come from springs in Bedhampton and Havant. So at the moment, Portsmouth Water uses water from these springs to supply, I think, around 30% of its customers. It's, I think, the largest spring source in Europe. And while we can make use of this water in winter and in times when the rainfall is much, much higher, the water, we can't make use of it all. And some of this water flows out to sea and into the harbours and is essentially wasted. So the purpose of the reservoir is to take this surplus water at times when there is more of it. We will pump it up through Havant, and for those of you who are familiar with the area, you can see it there sort of indicated on the map, and use it to fill the new reservoir. Our original design used open cut techniques, so it would have involved digging lots of trenches through Havant, and we recognised that this wasn't the ideal. It would have been incredibly disruptive for local people. So we've since developed a new plan, which involves tunnelling vast sections of the route. So if you look on the map, any bit that's got grey on it, that would still be open cut, and we've limited that to parts of the route that don't intersect with roads and pavements, and the rest of the route would be tunnelled. So work is due to start. We've got full planning permission for this new route, and work is due to start later in the year. So we talked a lot about the deficit at the start, which water companies are facing, in particular Southern Water, given that it needs to reduce abstraction from these two chalk streams in its supply area. So the reservoir will be able to supply 21 million litres of water per day, enabling us to share that with Southern Water. But the company needs to find 200 million litres in total. So that's, while that will help to some extent, it will only go sort of a relatively small part of the way. So Southern Water is looking at other solutions as well. And one of those is using water recycling, which is really well tested, well-established technology, which is already used all over the world. Process involves purifying treated wastewater, and it would enable the reservoir to provide an extra 90 million litres per day, and that's on top of the 21 million litres that the current approved scheme would supply. So I think it's worth saying that this proposal and this scheme is some way behind the current plans for the reservoir. So they are separate from the approved plans and are subject. They're going through their own sort of planning process at the moment. And if they did go ahead, it would still be very much a Portsmouth Water reservoir, with us keeping full control over the water coming in and out of the reservoir. But it would mean that the benefits of the reservoir would be much, much greater, or could be much, much greater in future. So I'm now going to pass over to Ryan, who is going to, I think, give a little update on construction on site. And I think that it starts with a video.
It does indeed. It does indeed. Yeah, should we watch the video? So the video just shows a little bit of what we've been up to this year. I'm not going to talk too much over it, but I'm going to point out some kind of key features as we go around. So what we're looking at in front of us here is the ground improvement zone. That effectively is the foundation of the embankment, and I will come back and talk a little bit more about that in a minute. That white concrete structure or grey concrete structure is our culvert. That's the main or primary inlet outlet for water supply. And then just in the distance there, you can see Lee Park behind the trees. Ooh. And as we continue a very startled flight around. Some more of our ground improvement zone going on underneath us. So this year we've been really focusing on getting the foundations down. Anyone with any construction experience would know good foundations make the rest of the job easy. You can see some of our kit working there. Just for reference, these dump trucks and excavators are 40 and 50 ton. The wheels on them are about 6 foot high. They look very small from the sky, but when you're next to them, they're much larger. And as we come to the north end of the site, this is where the main compound is situated at the minute. This will eventually become a visitor centre. And then as we kind of go along the northern flank, this is where the wetlands is going to be constructed. I won't steal too much of Mark's glory. Mark, I'm sure, will talk about the wetlands a lot. Those large basins there, they're to impound water. So rather than letting the water just freely flow over site, we do impound and over pump. Just some more of the wetlands. And some more stockpiles from around the site. It's a huge site. I don't know if Eleanor mentioned 160 hectares. So it's a very large site. I think it's just over a mile in its widest point. Brilliant. Amazing. So as you can see from that video, which was taken kind of mid-August, we've had a really good year this year, despite having a slightly wet end. September, the heavens opened. But yes, we've had a really good year. Oh, apologies. Sorry about that. Fire alarm.
Oh, we can't hear it.
Oh, can you not? Okay, well, I'll carry on talking then.
If you can.
So yeah, we've had a really good year with the earthworks, placing over 600,000 cubic meters of clay this year. But in total, the embankment is about 3.5 million cubic meters, which equates to around about 7.5 million tons of clay. All of the clay in the reservoir is site one, which means we remove it from the center of the site and we stack it up on the sides to form the embankments. So the material, no material is imported to build the embankment. That being said, sorry, I might have to leave if this fire alarm doesn't go off. I don't know. Anyway, I'll keep talking for a few minutes. With the material, we also have to. Oh, there it goes. Gone. Sorry. We also have to import some materials. So on this project, we're importing a lot of sand. The sand is used in the embankment for foundations. I always like to think of the clay underneath the reservoir is a bit like a sponge, and when you pile lots and lots of material, very heavy clay on top, it squashes that sponge, and apologies. And as the clay is stacked up on top of the ground, it squeezes it like a sponge, and it will slowly release water. It's quite a natural mechanism. It's nothing to worry about. And if that water isn't given a route to escape, it builds up in pressure, called pore water pressure. So we put down sand blankets and we put down finger drains and we put down toe drainage to make sure that that water has a path to leave. So that's why we're importing a lot of sand on the project. And also, interestingly, for a reservoir, it has a 120-year design life, which means we can't use natural materials like plastics and geotextiles. So we actually rely on older methods, using aggregates, using sands, using natural materials that are very stable, instead of using the kind of the plastics and the geotextiles, which haven't quite been tested to 120 years. I don't think much of them were around 120 years ago. So yeah, next slide, please, Eleanor. So yeah, that was a little bit about the GIZ, and the other kind of significant feature that we looked at in that drone footage was the culvert. So the culvert is a very large reinforced concrete structure. It's made of around about 15,000 tons of concrete, which is a significant amount. Its size is around about 7 meters wide and 6 meters tall, which means you could potentially, I don't think we'll ever be allowed to, but you could potentially drive a small vehicle, or actually probably quite a large vehicle down the culvert before it's fully completed. In its final state, it will be 230 meters long, and what the culvert allows us to do is to install pipework within inside. The culvert allows that pipework to be fully maintainable throughout its lifespan, its 120-year lifespan. And unfortunately, you can't see it yet on this image, but where there's a gap in the concrete there, that's where the valve tower is going to be formed. And the valve tower will protrude up through the embankment and be at water level. And that valve tower allows the valve to be replaced and maintained throughout the lifespan of the reservoir. The culvert and valve tower will form a bit of an inverted T shape, but you won't see that, unfortunately, once the reservoir is constructed and it's surrounded by clay and filled with water. Yeah, next slide, please. So as well as talking about construction, we'll talk about a little bit about some of the technologies, you know, kind of suit the audience. As I mentioned at the beginning, the construction industry, in my opinion, tends to lack a little bit in technology and innovation. So it'd be interesting to talk about. One of the big things we use on this project is machine control. Machine control integrates GPS signals and onboard sensors to kind of automate the positioning and operation of earth-moving equipment. The kind of earth-moving equipment we use are excavators, dozers, graders, and rollers. It all starts with a digital 3D terrain model. We kind of call it a surface, and the machine control system determines where the machine is sat in relation to that surface. What it allows us to do is dig very, very precisely, or grade or roll, whatever operation we're doing, very precisely to around about plus or minus 25 millimeters, which again, for a 40, 50 ton excavator is fairly good precision. That significantly improves things like efficiency. It improves safety and accuracy. And it also helps with kind of we call it automation, but it's not automation. It helps with kind of fatigue. It helps reduce the stress and reduce the I don't want to say attentiveness because that's probably the wrong word, but it reduces the fatigue. I'll leave it at that one. What it also allows us to do is collect a lot of information and data about where those machines have been working, how much clay they've shifted in a day, which for an earthworks project manager is very important. I need to know how efficiently and how effectively our machines are working, and without putting it too bluntly, who's making the most money and who's not, you know, making enough. There's more than money. We create the surfaces and the machine control information using drones, which, if I remember rightly, is the next slide. Sorry, I do apologize. I haven't looked at these slides since we were going to do this last time. Perfect. So one of the other kind of technologies we use on the project is photogrammetry and LiDAR. So you can see on the right there, there's a lovely kind of overview of the site. So that was taken about 4 weeks ago, and that is from photogrammetry. So it's lots and lots of photos that are stitched together. From the photogrammetry and the LiDAR surveys, we create the surfaces. And we do that for a number of reasons. Firstly, to provide information to the machine control excavators, rollers, dozers, but also for progress photos. And we also use it for flood modeling as well. And I probably should carry out flood modeling. Being a large site, we have to build a lot of temporary drainage. We have to build a lot of attenuation basins, many of which you saw in that video. So having live and up-to-date information, especially right now as we start going into the winter seasons, is really, really important. Next slide, please. One other thing that kind of comes with machine control, this is a bit of a tangent to machine control, is a fairly new technology called continuous compaction control. Sorry, it's a bit of a tongue twister. We use continuous compaction control, or CCC, to manage and monitor our compaction areas. So when you're building an embankment, your layer compaction is one of the most important kind of parameters. Your layer compaction will determine the density and strength of the clay and how it performs, and ultimately creates an impermeable, or helps contribute to creating an impermeable core. So the continuous compaction control is really, really important for us. We use it in a context of, as you can see kind of in the example photo here, of counting the number of passes. So our target passes is 8. This isn't a live photo from our project. It was taken from the manufacturer. But we could see in a very visual format where areas have been compacted correctly, where they might have been over compacted, because that's also an issue, over compaction, or where they might have been under compacted. And it allows us to address those issues very, very quickly. And we kind of have live feedback on site, and data collection. So there's a few kind of technologies that we're using on the project, and a very kind of brief construction overview. And I will hang around at the end as well and answer any questions if anyone has any questions. Yes, I think handing over to you, Mark, if that's okay.
Yeah, of course. I can see a couple of questions coming in the chat,
Yeah.
Ryan, so you can have a look at those and prepare yourself for responding. Okay, thanks very much, Ryan. It was really, really useful and really interesting. So as Eleanor was mentioning at the beginning, and just for anybody that joined late, I'll just introduce myself. So I'm Mark Jessup. I'm the environment manager working for Portsmouth Water on the project. The project itself is, and always has been, committed to delivering the best possible outcome for the environment. So there have been many sort of planning application requirements and commitments that we have in place, which includes the landscape ecology and management plans. We've got biodiversity mitigation and compensation strategies. So there's a lot of work and preparation that's gone into making sure that we minimize the impacts of the reservoir on the environment, and also that we compensate for it correctly. So Eleanor may have mentioned, yes, we did. We're planting and improving more than 200 hectares, both on and off site. This has included the restoration of local woodlands in the area, watercourses and ponds. We've also created a lot of new woodland and woodland pasture, and also wetland habitats and open water areas as well. And we, as part of our early environmental net gain, we planted over 6,000 trees back in 2019, which was above and beyond the commitments we were required to do, just because we felt it was the right thing to do, and we always wanted it to be an environmentally led project. Other aspects of the environmental compensation has included the translocation of trees and plants, which Eleanor had mentioned before, and also creating new roost features for bats, as well as other wildlife species. So next slide, please. So interestingly enough, I mean, we're now in 2025, but monitoring of the sites started in 2005. This was basically to understand the site better. It was Portsmouth Water owned land. It was, as you can see from that picture, other than being lovely weather back in 2005, it was sort of pasture and sort of meadow. There was one area of ancient woodland that went up. It was called the Avenue. It went up from the south of the reservoir site, from Staunton Country Park, which is our immediate neighbour. There was an area, so that area of ancient woodland ran in across the site. Yeah, most of it was sort of small ponded areas and sort of wet pasture. So a lot of the work was to understand how they could relocate the species, what species were actually on site, and just start that work to try and save as many of the wildlife that could possibly be impacted by the project. So we ended up translocating an enormous number of reptiles, macroinvertebrates, and macrophytes. So for anybody who doesn't know, macrophytes are very small sort of aquatic plants, and macroinvertebrates are very small animals with no backbone, I believe. That's the technical way of identifying them. So yeah, so we created lots of new habitats all around the edge of the reservoir area. We're quite lucky because as a site, it's located in a natural bowl area with woodland almost all the way around it. And so there were a lot of opportunities to identify locations to transfer those species to. There was a plan of a number of ponds throughout the local woodlands just to make sure that when things were translocated, they were placed in the right type of environments and they weren't all put into one pond because obviously monitoring them or under, continuing monitoring them was important to make sure that they survived and thrived in their new homes. So yeah, so there was a stalling of around 200 bat boxes and 300 dormice boxes all around the nearby woodlands, which are monitored and surveyed continuously, and have been very successful to date. Next slide, please. So this is just to give you an idea. That was way back in 2005. Obviously, construction has already started, and you saw the aerial drone footage that showed you what the site looks like now. But however, it's very difficult to explain to the local wildlife that they really shouldn't come on the site, and it's really not the best location for them. So there is a number of what are called ecology clerks of work, which are ecologists that monitor all the works that are going on, and they will continually rescue and translocate species that enter the site. And that is an ongoing piece of work. But as you can see from these numbers, this was just in 2024. There's still a significant amount of wildlife that comes onto site. And in fact, this year, because it varies every year, I mean, there it says that there was one bucket of common frog spawn in 2024. Earlier in February this year, 2025, there was 1 week where 12 buckets of frog spawn were carried off site. So, you see these ecologists like traipsing across the site with their buckets of frog spawn. So there's a big effort, big concerted effort to rescue as much from the site as possible and to reduce those impacts. Next slide, please. So yeah, so obviously some species are covered under the European Protected Species license. So we work closely with Natural England. We have European Protected Species licenses in place for bats, hazel dormice, and GCN, which is great crested newt. And yeah, monitoring surveys are always being undertaken as part of the requirements and the obligations related to those licenses. So in 2023, bat monitoring surveys recorded, amazingly, a minimum of 12 bat species. I believe there are only 17 different bat species that have been identified in the UK. So that's amazing. And we've also been contacted by various bat groups to say, well done on all of the surveying and monitoring that you've carried out, because this has really helped us to understand a lot about different types of roosting that goes on in the south of England. Some of them are quite rare. There's three species that are actually breeding, which is really good, and then there are three very rare species to the UK, which is a barbastel and a Beckstein and an alphaco, I believe is what it's called. Bats are not my speciality, but I have to admit we do have a couple of people on our team that love bats and know everything about bats. So if anybody has any specific bat questions, I can certainly take those away. And then interestingly about the great crested newt, so it was a bit strange, really. We did eDNA surveys throughout all of the woodland areas and the ponding areas. We have these wonderful, beautiful habitats, and all of the results showed no presence of great crested newt. And then the very last pond, which is part of a small drainage ditch right next to the site's gate, identified great crested newt had been there. And so obviously we had to put that protected species license in place for that. And so I jumped ahead a little bit there. Obviously, hazel dormice, which are the cutest things ever. And they have been successfully breeding around the site as well. And we've had little nests and footprints. We've created a number of new little habitat boxes for them, and they are monitored, surveyed, and protected. And when we do find them, they're usually asleep, and they're normally absolutely adorable. So as you can tell, I'm a bit of a fan. Okay, next slide, please. So I mentioned about the tree translocation, and I know that Eleanor had mentioned the word going above and beyond. And it's certainly something that was very important to us, and community involvement was also very important. So I mentioned about the avenue, the area of ancient woodland that crossed the site. Um, it unfortunately had to go because we needed to build the reservoir. Um, Impacting ancient woodland is never well received, either regulatory or by local communities, because they're very rare and they're impossible to mitigate, of course, because it's an ancient woodland and you can't recreate an ancient woodland. So there was a big initiative to try and save as much of it as possible. That included the rescuing of saplings, ancient woodland soil, small trees, and rescuing them from that area. A lot of the ancient woodland soil was placed along the northern edge of the project area, with the aspiration to try and plant some of the saplings once they had grown to to a good size in those locations. So we decided to incorporate the community to help us with this, and there was a big initiative to rescue as much as possible. We ended up rescuing about 450 trees. All of them were potted in biodegradable pots with ancient woodland soil. They were all kept at Portsmouth Water HQ offices in Havant. They were tended to for 2 years by members of Portsmouth Water staff, and basically they survived really well. And then last year they were replanted all around the project area, and have been thriving and doing really well. It was so well received by the local community that we had a couple of sort of groups that were sort of opposed to the project. One of them was called Stop the Chop. They were so thrilled to be sort of involved and be a part of this initiative. They changed their name to Havant Thicket for Nature, and that I think is a good testament to how incorporating the local community in some of your initiatives, and particularly when it relates to environmental impacts and how to mitigate them, is very rewarding. Okay, next slide, please. So obviously, it's all very well just doing a lot of planting. As I said, we did this of 6,000 trees, advanced planting. We translocated a lot of these ancient woodland saplings. We even translocated a couple of 4 large oaks. Well, not large oaks. I mean, that's that picture on the top right there, but fairly sizable, not saplings anymore, that were along a bridle way that was impacted by the site. But of course, you can't just plant them and leave them. They need to be taken care of. I mean, how many times has everybody been driving along a road or a new A road or a motorway? You've seen all the mitigation planting, and basically, there's lots of sticks that are dead, sitting in plastic tubes, because no one's actually following up and taking care of them. So that was a very important thing for us to make sure that everything survived and thrived. So we have a landscape aftercare contractor that we've employed on the site with an extended contract to undertake a ongoing program of sort of seasonal works. Obviously, this varies from season to season, but it includes sort of grass cutting, weeding, and trimming around the areas, construction of hibernaculars, as you can see in that picture there, which is some of the sort of the dead wood from Havant Thicket woodland, is used to create habitats for small species and wildlife. They maintain all those tree guards, and one of the serious things that they've had to do this year, of course, is watering. So they have these great big tanks of water that they've been going around, making sure everything is well watered and survived. And we've had a fantastic rate of survival of all of our advanced planting and our translocated planting as well. So yeah, that's really been a very important aspect of maintaining these things. And I will mention one thing as well, and it sort of ties in the local community and the environment, is that one of these advanced planting areas, actually the one on the left-hand side, the Memory Park, which has actually grown quite a bit more now, was set fire by some vandals over the summer. Fortunately, it looks like the damage is going to be able to regenerate mostly naturally. But one of the local schools who have been taking a big interest, primary school that have been taking a big interest in the project, wrote us a letter. And they said that they were really upset to hear about the fire, and was there anything that they could do to help replant any new saplings, or is there any work that they could do to try and help the area recover, which was completely adorable. And it's nice that the local community are taking such a vested interest, especially young people. We've had a lot of young people very interested in the reservoir, who are very interested in getting involved in that type of work when, quote unquote, they grow up. So that's always good. And some interested in engineering as well, Ryan, don't worry. And next slide, please. So I mentioned about that Havant Thicket woodland. We work very closely with Forestry England. We have what's called a Section 106 supplementary agreement with Forestry England. They have a large area of woodland, which is sort of semi-ancient woodland, right just north of the site. And we have a commitment with them to continually improve that woodland as part of our mitigation and compensation sort of strategy. Some of the work that they undertake is ride and glade management, which is where they trim back and manage the walks and the bridleways. They are doing a lot of replanting, so they veteranize trees that are not native to the area, which basically means that it's called ring bark them, where they cut round the bark, allows the tree to die, and then it becomes like a natural sort of habitat for different types of invertebrate species. And then there's a lot of planting going on of more native species. There's pond enhancements, like I say, thinning of the conifers around the ponds. And then right at the bottom there is INS management, which is quite a big thing, which is invasive non-native species. There are quite a lot of invasive species throughout the area, which we are managing because we do not want to have invasive species entering the site. Some of these are called Japanese knotweed, Himalayan balsam. You've probably heard of some of them. They're quite prevalent and like they are non-native. We had one pond in Havant Thicket woodland that had parrot's feather in it. And parrot's feather is very popular with people who use aquariums. And it seems that somebody decided to dump their aquarium water into one of the ponds, because we have quite a lot of urban area around the site. And then it became quite uncontrollable, this parrot's feather. And fortunately, we've managed it, sprayed it, and keeping it under control. But it's something we're keeping an eye out for, and we have an management strategy to make sure that we're on top of that. Okay, next slide, please. So I've talked a lot about what's been going on site with regards to some of the translocation and things like that. We also have a couple of off-site mitigation and compensation projects. One of them is at a farm which is located probably about 4 kilometers northeast of the reservoir site. It's called South Holt Farm. It's a long-term management plan, 80 years, for rewilding of agricultural land by creating 60 hectares of woodland and woodland pasture, and 20 hectares, and woodland pasture, and about 20 hectares of grassland to compensate for biodiversity impacts from the reservoir site. It's a company, charity called the Pig Shed Trust. Nothing to do with pigs. They first set themselves up in an old converted pig shed, hence the name. They're a conservation charity. They have done one of these projects before, and they are managing the land and overseeing the creation of these biodiversity habitats. The project, as I said, will run for about 80 years. And will create a connectivity and a sort of mosaic of ancient and semi-natural woodland, in addition to the woodland pasture and some of the grassland. One of the key managers of this land is the cattle. So we have a lot of cattle on site. We also get a lot of calves that are born, and we always get some lovely photographs of all the new calves, and which are all named. I think we're on B's at the moment. So there's a sort of a Bobby, a Belle, a Brian, and they're very sweet. They have no fence collars, electric collars. They get to roam the land sort of at will, and along with their poop, they also churn up a lot of the soil naturally with their hooves. They'll be on site for their whole lives. They'll never enter the food chain or the dairy industry, and so it's a lovely story, and we enjoy taking people for a visit to the site to meet the cows and also listen to Harvey, who is the head of the Pig Shed Trust, talking about how the land is being managed for wildlife. Okay, next slide, please. And then the other area of off-site mitigation is Southley Forest. Southley Forest is an area of woodland not far from the reservoir site, again, just to the northeast. It's been owned by Portsmouth Water since the 1960s, but hasn't really been managed other than for health and safety reasons and for recreational purposes. So it's got some footpaths in it, but from an ecological perspective or biodiversity perspective, it hasn't really had any work done to it. So it's about 74 hectares. We've entered into an agreement with the Hampshire and Isle of Wight Wildlife Trust, who are going to manage that woodland, and they'll be undertaking ecology surveys. They're installing a lot of bat boxes. Again, our bat surveys have identified an enormous number of bats in the area. Some, again, are the very rare variety. And they have a conservation management plan where they're going to start removing some of the old conifers and some of the old pines that were part of a plantation, and removing those from site, and replanting and growing some more native species. So yeah, so the idea is that we'll slowly work it back to a more natural semi-ancient woodland or broadleaf woodland, and manage it from an ecological perspective. We have a lot of signs in the woodland explaining the work that we're doing to the local public, and get quite a lot of support from local residents who are supportive of the work we're doing. And again, I did get my bat names right. Okay, so it's the Beckstein, Balbastel, and the Alcatho bat. It's very, very rare, and we're sort of proud to have them on site. The next slide, please. And finally, I wanted to touch upon the aquatic mitigation and compensation that we're doing. So, talked a lot about the environmental work we've been doing with translocating flora and fauna. But of course, there were impacts to watercourses, unfortunately, on the reservoir footprint. So there was about 3.8 kilometers worth of watercourses or headwater streams that were impacted by the reservoir. There are 3 headwater streams that come down from Havant Thicket woodland that would normally enter the site. When you saw those aerial drone footage, you'll have noticed those ponds that Ryan mentioned. They are collecting the water that would normally run into those streams, and containing that, and then treating it and pumping it off site. But there's obviously these impacts need to be mitigated for. There was a conversation with the Environment Agency. The Environment Agency sort of agreed that it was impossible to recreate 3.8 kilometers worth of water courses in the same catchment area that's actually quite urbanized. So it was agreed that we would undertake 5.5 kilometers of watercourse restoration and pond enhancements across 14 different watercourses throughout the local catchment area. This was through the Environment Agency's Water Framework Directive, Mitigation and Compensation, which is Regulation 19. Used to be called Article 4.7. So we ended up having a big mouthful calling it Water Framework Directive, Mitigation, Compensation, Article 4.7, Regulation 19. So we ended up just calling it Article 4.7. And that work has been underway for a number of years. It includes various different types of stream and watercourse improvements. Some of them involve just creating what we call leaky woody dams, which are just creating natural barriers along some watercourses and allowing them to create natural ponding areas to allow habitats to thrive. Some of them are much larger. We currently have two projects that we're procuring design build contractors. One of them is a Waterlooville golf course, where they have well, you can see it in the bottom left-hand corner. They have a sort of a channel that runs across the golf course. The banks are starting to cave in. We've offered to step in, create a more sinuous natural watercourse, create some biodiversity habitats and habitat creation on the sides. They're happy to get some free landscaping, and we meet some of our objectives for watercourse improvements. And then the big one is in Lee Park, which is the large council estate in north of Havant. There is a channel called Hermitage Stream that back in the 60s, because we all know how they like to do things in the 60s. So it's just a concrete channel that just runs straight down the middle of the housing estate. So that's about 2.2 kilometers. And the plan is to dig up the concrete and try and make it more sinuous again and add biodiversity habitats and create some natural habitats along the banks. There on the left-hand side is it's a sort of a drawing artist rendition of how it should look, and then how it currently looks at the moment. So, and then just one other thing I'll just add, which is a sort of an interesting good news story, was as part of this work, we did impact on some aquatic plants, three of which were very, very rare to the Hampshire area. So we tried to translocate them and hope they would take, but we had a backup plan where we worked with Kew Gardens and the Millennium Seed Bank. So while we were waiting for our translocated species to hopefully work, they were germinating some seeds that were apparently quite challenging, and they actually developed some new processes for germinating particular types of seeds. And after 2 years, they had created about 480 different plug plants that they'd grown for these three different species. And this September just gone, we had a big volunteer planting day where Kew Gardens and Millennium Seed Bank representatives came down, and we had local volunteers, and we planted them around some of the ponds in our Havant Thicket woodland. They're being monitored to make sure that they thrive. And again, I think it just shows sort of a commitment that we have to trying to preserve and compensate for impacts to the environment. Okay, next slide, which I'm not sure if there is a next slide. Well, there we go. Thank you very much.
Thank you. Thanks, Mark and Ryan.